In this program, we'll take an in-depth look at the R129's new features and introduce the new diagnostic manual. Before viewing this program, you should have first seen the videotape in the R129 kit covering development and systems operations. Let's begin our introduction of the R129 by looking at the engines that will be installed in the 300SL and the 500SL. Keeping in mind that many features will be common to both engines, we'll look first at the M104 in the 300SL. This 3-liter straight 6-cylinder engine is based on the M103 used in the 300 series automobiles. However, unlike the M103, the M104 is a 24-valve, twin-cam design with a 10-to-1 compression ratio. It produces 228 horsepower at 6,300 RPM and 201 foot-pounds of torque at 4,600 RPM. The red line is 7,000 RPM. The M104's open combustion chamber and high compression ratio mean greater overall efficiency and power. A side benefit of using the 4-valve per cylinder design is that the individual valves are smaller and lighter. This means less valve spring pressure is needed, which translates to less wear on both the valve seat and the camshaft. Piston cooling by oil spray is a feature that has been used on the turbo diesel engines. The M104 now uses an oil spray to lower piston crown temperature by about 86 degrees Fahrenheit. Cooling the pistons this way helps ensure an unchanging clearance between the piston and the cylinder wall. This provides both significantly improved piston lubrication and less engine noise, even at high speed. The cross-flow design of the cylinder head has the 2 intake and 2 exhaust valves for each cylinder positioned opposite each other at a 50-degree angle. The roof-style open combustion chamber design provides for what engineers call optimum volumetric efficiency. Basically, this means that the engine can breathe better. That is, it can inhale the intake charge and exhale the exhaust gases with great efficiency. The higher compression ratio was made possible in part by a centrally located spark plug that provides a 45% shorter flame travel compared to the M103's combustion chamber. Better flame travel helps prevent incomplete combustion and engine-damaging knock or pre-ignition. In addition to the combustion chamber design, the M104 uses 2 knock sensors to control pre-ignition. Mounted to the block, these sensors contain piezoelectric crystals that listen for the early signs of pinging or knock. The noise associated with pre-ignition produces a voltage signal in the sensors. This signal is then sent to the ignition control unit, and the timing is retarded for each individual cylinder. But the problem with retarding ignition timing is that the greatest engine efficiency occurs at a point just before pre-ignition occurs. So, while retarded timing prevents damage, at some point, engine efficiency decreases. Therefore, unlike other manufacturers' designs, the Mercedes-Benz system will only retard the timing on the cylinder where the pre-ignition occurred, rather than on all cylinders across the board. This is possible because the ignition control unit receives information on camshaft position, so that when a knock signal is detected, it knows which cylinder is at fault. Depending on the intensity of the pre-ignition knock, the ignition control unit will retard the timing for a particular cylinder between 2.5 to 5 degrees per ignition cycle, up to a maximum of 10 degrees. However, the system will also take engine temperature into account. So, for example, the maximum retard of 10 degrees will only occur when the coolant temperature reaches 90 degrees Celsius. At 30 degrees Celsius coolant temperature, maximum ignition retard is only 3.5 degrees. If one of the NOx sensors fails, the ignition control unit retards the timing on all cylinders in order to prevent damage. Another engine design change involves the use of a spark plug with a flat seal in place of the previously used conical plug. This was done both to minimize over-torquing problems and to improve sealing. Turning our attention to the valve train, you can see that the intake and exhaust camshafts are driven by a double roller chain. Attached to the intake camshaft, you'll see a new component. This adjuster allows us to change intake valve timing for maximum efficiency according to the demands of the engine. In order to appreciate the benefits of the camshaft timing adjuster provides, we'll take a brief look at the concept of valve timing. Valve timing is simply the point where a valve opens relative to the number of degrees before or after top dead center of piston stroke. Valve timing is important because it directly affects engine breathing or the volumetric efficiency I spoke of earlier. This brings us to an inherent engine design limitation, namely that for the best volumetric efficiency, different valve timing is needed at idle, mid-range, and top end. Therefore, all prior engine designs have been a compromise. Before the use of variable cam timing, in order to get a very smooth idle, the engineers used a camshaft that had a valve timing that was somewhat retarded compared to a camshaft designed for mid-range power. The problem would be that the engine would trade off a loss of mid-range power for the smooth idle. But for optimum power at mid-range RPM, the intake valves need to open earlier to get the fuel-air mixture to fill the cylinder efficiently. Here, we'd want to remove our idle camshaft and install one with advanced valve timing. The result would be good mid-range power, but we would pay the price with a very rough idle. Also, above 5,000 RPM, the same valve timing that produces mid-range power actually reduces volumetric efficiency at high speed. So, to get the best top-end performance, we'd need to install a camshaft that will retard valve timing. What the new camshaft timing adjuster allows us to do is to have the best of all worlds with a no-compromise design. Here's how it works. At idle, the intake camshaft is in the retarded position. The result is reduced valve overlap and an incredibly smooth idle. When engine speed increases from between 1,000 to 2,000 RPM, a signal from the CISE control unit opens this magnetic valve. Oil pressure then forces a piston, which then moves this helical gear. As the gear moves, it rotates the flanged hub that is bolted to the intake camshaft. Valve timing is then changed from retarded to advanced. This allows better breathing at mid-range RPM, and mid-range power is therefore increased. When engine speed exceeds 5,000 RPM, the CISE control unit de-energizes the magnetic valve. The camshaft is again rotated relative to the drive gear, and valve timing is retarded. Engine breathing or volumetric efficiency is improved for high RPM, which means more top-end power. Let me show you briefly how all this looks in practice. If we advance the intake valve timing at idle by energizing the advance unit, engine idle is poor. Why? Because the increased valve overlap needed at mid-range is reducing our volumetric efficiency at idle. When you retard valve timing and reduce valve overlap by de-energizing the advance unit, the idle smooths out. Now, let's look at the fuel system. Both engines in the R129 will use the CISE 5 injection system. This system is similar to the previous CISE, but with the following changes. The first is easy to spot. The airflow sensor plate has been modified into a special aerodynamic shape that provides a more efficient airflow into the engine. System pressure has been increased to between 6.2 and 6.4 bar. And the opening pressure of the injection valves is now 4.3 to 4.6 bar. The injection valves themselves now have seals made of a Biton material. Both the increased opening pressure and the Biton seals will help performance under hot start conditions. Another change is that the CISE-5 control unit exchanges information with the EZL control unit. This means a greater capacity for engine management. On the M104 and M119 engines, the signal to change valve timing comes from the CISE-5 control unit. Looking under the hood, you'll see this MAS engine systems control unit, referred to in the literature as N16. It's connected to the wiring harness with a new style positive lock connector. To remove it, twist the cap connector. The MAS engine systems control unit combines the following functions: fuel pump relay, AC compressor control unit, MAS onboard diagnostics, control of the O2 sensor heater and air injection system, and the maximum engine speed cutout. Looking at the CISE-5 control unit, you'll notice that the connector is now fastened with a different positive lock connector for additional reliability. The CISE-5's diagnostic system has a capacitor-based hard memory and will store intermittent faults. In order to perform the onboard diagnostic tests for the CISE-5 system, you'll need the new engine diagnostic manual, this test adapter, and the new socket box. Let me show you how to go about troubleshooting the system. In order to check the blink code, plug in here at the X11-4 diagnostic connector. By the way, you'll find all component locations and procedures in the new diagnostic manual. With the ignition on, check to see if any fault codes are present. Code 5 indicates a problem with the O2 sensor signal. And, according to the diagnostic manual, you will need to go to test step 14 to check it out. Step 14 tells you to connect the socket box to N3. Now, how do you know what N3 refers to? Just turn to the illustration in the diagnostic manual. You'll see that N3 is the CISE-5 control unit. After making the connection, check between pins 32 and 13 with a voltmeter. Now, let me pause a moment to caution you. Because the diagnostic manual contains a wealth of information, it may seem overwhelming. It will take some study in order to become familiar with it. Okay, all of the features we've looked at on the M104 six-cylinder apply to the M119 V8 as well. To review, they include 4 valves per cylinder, variable intake cam timing, and the CISE-5 fuel system. Compared with the 5.6-liter M117, the M119 displaces 5 liters, produces 322 horsepower at 5,500 RPM, and 332 foot-pounds of torque at 4,000 RPM. The red line is 6,000 RPM. The 4 camshafts are made of alloyed chilled cast iron and are supported by 5 main bearings. By the way, in order to remove the intake camshafts, you must first disassemble the cam advance mechanism by removing these bolts. On the M119, when reinstalling the camshafts, use the special tool to line up the installation hole on the camshaft flange with the hole in the first bearing cap here. The installation hole on the flange is located 45 degrees before top dead center of cylinder number 1. Two transmissions will be available for the R129. The M104 is mated to either a 5-speed manual transmission or a 5-speed automatic. The M119 is available only with the 4-speed automatic. For smooth operation, the manual transmission uses a new tandem or 2-mass flywheel. The spring dampening system reduces noise by minimizing the effects of torsional movement. The only permissible repair is the replacement of the ring gear. Both automatic transmissions used in the R129 have a new transmission overload protection system. In order to protect the bands and clutches during high-speed shifting, the system will retard ignition timing in order to reduce engine torque for 400 milliseconds. The system also improves the quality of the 2-3 upshift at full throttle. The overload protection system is integrated into the ignition control unit, which receives a signal from the S65 switch. Adjustment of the control pressure for the automatic transmission is very simple. On the 300SL, turn this adjustment nut, referred to as number 15 in the literature, so that these indicators point to each other. On the 500SL, turn the adjusting nut until the arrow on the spacer tube aligns with the adjusting nut. The automatic transmission will be equipped with a new parking lock. This prevents unauthorized operation by locking the transmission lever in the park position when the ignition key is removed. Also, removal of the ignition key will not be possible unless the shift selector is in park. In order to adjust the mechanism, first shift the lever to neutral and turn the key to position 1. Loosen the attachment bolt and pull the cable jacket until the locking lever reaches the cam plate. Finally, retighten the attachment bolt with a torque of about 5 Newton meters. Check that the adjustment is correct by making sure the ignition key cannot be removed with the selector lever in drive. Then shift the lever to park and check to see that the key can be removed. With the key out, you should not be able to move the lever. The automatic roll bar reduces one risk of injury usually associated with driving a convertible. It's made of high-strength steel and covered with polyurethane foam padding. The roll bar can be raised manually with this switch. Or it can be stored out of sight. It also raises automatically in the event of an emergency. This is the roll bar support and operating mechanism. It's mounted here at the passenger side B pillar. A support unit only is mounted at the driver's side B pillar. Components in the roll bar system include the electronic control unit, the manual operation switch, the indicator lamp, the left and right rear axle switches, the support and operating mechanism, the hydraulic pump located in the trunk, and the roll bar hydraulic valve block located here. The roll bar is raised manually by hydraulic pressure acting on the operating unit. In order to lower the bar, oil pressure from the hydraulic pump enters the operating unit and overcomes the pressure of the activation spring. In the type of emergency that could lead to a rollover, a signal from the control unit releases an electromagnet. The spring tension stored in these units is released, and the bar is raised into position in about 3/10 of a second. There are two ways that the control unit will release the electromagnets and allow the spring to push the roll bar up. First, if the control unit senses an impact of 4 Gs in any direction. And second, if either of the two rear axle switches open the circuit to the control unit and the control unit senses a 23-degree tilt angle, the axle switches are normally electrically closed and open when the suspension springs extend. Actually, there is a third way the roll bar can be raised automatically, and that is when you put the system in the test mode through the rear axle switch. You'll notice that the rear axle switches have two positions: the function or operation position, where the switch arm is fully movable, and the arretiert position, which is the German word for locked. In this position, the roll bar system activation can be checked by making a quick stop from approximately 6 miles per hour. Problems in the roll bar system will be indicated when the warning light in the instrument cluster illuminates. Additionally, the roll bar switch will blink to inform the driver to raise the roll bar manually in order to be assured of its protection during an accident. Faults in the system can be diagnosed via a blink code. Turning to Volume 1 of the diagnostic manual, you'll connect the impulse counter to the X11-4 test connector. Press the start button for 2 to 4 seconds to recall a malfunction from the system's memory. Detailed testing is performed by connecting the socket box between the control unit and the wiring harness. This is done with the new 16-pin adapter cable. You can now use the chart in the diagnostic manual along with a DMM5 or Fluke multimeter. Since we got an impulse display 3, we would first connect a voltmeter, indicated by this symbol, between terminals 2 and 10 on the socket box, which is indicated by this symbol. We can now check the voltage according to the chart. With the ignition off, we need between 11 and 14 volts. As you can see from the chart, there are 5 other checks to make for the same impulse readout number 3. Looking further at the diagnostic manual, you'll notice that several of the tests for other impulse readout numbers do not use the socket box. For example, the first test under impulse readout 4. As you can see, this calls for putting a voltmeter between pin 4 of N53 and pin 1 of the X55-3 connector. The diagnostic manual will be your primary troubleshooting reference, so you should be familiar with the test procedures it calls for. Next, let's look at the R129's central locking system with infrared remote control. The infrared system consists of a transmitter housed in the key switch, 3 receivers, 1 located in each door, and the third located in the trunk lid, and a control unit located in the right side of the trunk. By pressing the transmitter button, the vehicle can be locked or unlocked, or to close the windows, simply hold the transmitter button down. The windows will stop closing if you release the button or if the infrared beam is blocked. The windows can also be closed by holding the key over in the lock position. With new batteries, the transmitter is effective from a distance of up to 6 meters when pointed at a receiver in the door or trunk. The distance will be less in bright sunlight or if the transmitter is aimed from the side instead of straight on at a 90-degree angle. When locking the car, the red light will blink for about 3 seconds. If the locking command cannot be carried out, for example with a door that is not completely closed, the light will blink for an additional 10 seconds. After then closing the door or trunk lid, you must first unlock the central locking system before relocking it. Now, here's how the system works. The transmitter sends an invisible beam of infrared light to one of the 3 receivers. The receiver then sends a signal to the control unit. On receiving the proper signal, the control unit activates the central locking system, the interior locking system, and, if requested, closes the windows. The signal from the infrared transmitter will also arm and disarm the anti-theft alarm. The system can only be operated with the transmitter that belongs with that particular car, since the signal from each transmitter is specially tuned to each control unit. Every time the control unit receives a signal, it automatically switches itself to the new coding that will be sent by the next signal and locks out the coding from the previous signal. The signal from the transmitter consists of a fixed code, which is then modified in the control unit. Since the modification of the code changes with each use, the security of the system is protected. You should be aware of two situations where it will be necessary to resynchronize the transmitter to the control unit. The first is where the button on the transmitter is pushed while outside the range of the receiver. If this occurs more than 250 times, resynchronization is needed. The second situation occurs when the batteries in the transmitter are replaced. By the way, the batteries should last about 1.5 to 2 years. A quick test to see if there's any battery power is to hold the transmitter button and watch for the LED to blink. If you want to check the condition of batteries prior to troubleshooting the system, you should get 1.35 to 1.45 volts with batteries in good condition. Now, in order to resynchronize the system, simply point the transmitter at a receiver and press the button. Then, within 30 seconds, lock or unlock the car using the key. That's all there is to it. In order to troubleshoot the system, we'll again turn to the diagnostic manual. The first thing to do is to go through the 8 steps in the function test in order to check that the system is working the way it's designed to. If you skip over a preliminary step, you may find yourself wasting time and effort in an unnecessary diagnostic procedure. For example, if the batteries in the transmitter are too weak, or if the unit needs to be resynchronized, why bother checking the rest of the system? These conditions will not even be detected by the impulse counter, which we'll look at in a moment. Okay, after you've gone through the preliminary steps, you then connect the impulse counter. Looking at the diagram in the diagnostic manual, you'll connect the counter to the X11-4 test connection. The system will store intermittent faults and has a hard memory, meaning that the faults will be stored even after the battery has been disconnected. A number from 1 to 14 will appear. Each is related to the chart in the diagnostic manual. As with other impulse tests, recall fault codes until the original code number reappears on the tester, which indicates no further fault codes are in the memory. Also, after the malfunctions are repaired, all fault codes must be erased individually using the impulse counter. And by the way, you only have 10 seconds after recalling the code to start erasing. One final point. If the impulse counter shows no codes, but if a problem exists, you should perform the complete test procedure using the socket box, as shown in the diagnostic manual. The socket box is connected to the N54 control unit located in the trunk with the test cable. Like other connectors in the R129, the cable is retained with a positive lock. The tests are then run with a DMM5 or Fluke multimeter, according to the diagnostic chart. The instrument cluster is a 3-piece unit consisting of a housing, electronic circuit boards, and a rear cover. For better visibility, lighting is now supplied from the rear by 4 2-watt bulbs. The instrument cluster has a new feature that will help you in diagnosing problems. It's now possible to get a digital readout through the outside temperature indicator for the following: quantity of fuel in liters remaining in the tank, instant fuel consumption, engine oil pressure, and engine RPM. It's also possible to check the position of the instrument needles, which we'll show you in a moment. To access the self-diagnostic feature, using a pen, simply push the center of the clock adjusting knob in for 5 seconds, and you'll see the first display appear. If you look in the diagnostic manual, you'll see how this information is obtained and interpreted. The reading 70.1 means that we're looking at code number 1, which, as you can see from the diagnostic manual, indicates fuel tank content in liters. So the .1 means code number 1, or fuel, and the 70 means that there are 70 liters of fuel now in the tank. If you now pull the knob out and turn it clockwise, you'll go to the next step in the digital readout, which is code 2, or instant fuel consumption in liters. Again, the .2 means code 2, and the 36 means that the engine is consuming fuel at a rate of 36 liters per hour. If you checked step 2 while driving, you would get a reading of fuel consumption in miles per gallon. Pull the knob again and turn it clockwise, and you'll be at readout number 3, which is engine oil pressure in bar. The .3 indicates step 3, and the 0 indicates engine oil pressure of 0 bar. Pull and turn the knob again, and you'll be at step 4, which is engine RPM. Step 5 is for engine oil level. Steps 6 through 9 position the instrument needles. Step 6 puts each needle in the first quarter of the gauge. Step 7, the second quarter of the gauge. Step 8, the third, and step 9, the fourth quarter. This feature will be helpful when you are diagnosing a problem concerning the instrument cluster. If you look at the diagnostic chart, you'll see a series of possible complaints, causes, and test steps. Let's say that the complaint is that the fuel gauge is either inaccurate or not operating. According to the charts, possible causes are the gauge itself or the sending unit. We are next referred to tests 3, 3.1, and 3.2. Now let's look at the troubleshooting procedures for the R129's new climate control system. The push-button control unit has a self-diagnostic feature that will record in memory both current and intermittent faults. The system has a hard memory feature that will allow intermittent faults to remain in storage even if the battery has been disconnected. To call up a fault code, turn the temperature dial to the white field. Switch the ignition on, and within 10 seconds, simultaneously press the Fahrenheit, recirculation, and rest buttons, and hold them down for 2 to 4 seconds. A fault code will appear in the temperature display window. After each fault code is displayed, press the recirculation button again and record each code. Do this until the word end appears. You have now read all the ongoing current malfunctions. Now, in order to call up the intermittent malfunctions, press the recirculation button again. This symbol will appear after each fault code to remind you now that these numbers are for intermittent faults. Continue pressing the recirculation button until you see this symbol, indicating that there are no further intermittent code numbers. With the climate control system, you can now erase all the fault codes together. To do this, turn the ignition on and press the recirculation, rest, and top arrow buttons simultaneously and hold for 2 to 4 seconds. This symbol, 3 dashes, will appear indicating erasure is complete. The second part of the climate control self-diagnostic system checks the temperature sensors, the potentiometer, and the feedback potentiometer. To get into this test mode, press the recirculation button once again after the end display appears. The display will now alternate between blinking the number 2 and showing the in-car temperature in degrees Celsius. Table B in the diagnostic manual is your guide to the 5 temperature sensor codes. Here you can see the temperature inside the car as reported by the in-car sensor is 21 degrees Celsius. According to the chart, the actual temperature inside the car must be within 1 degree Celsius of the reported temperature. Pressing the recirculation button again gives us code 4, which is the outside temperature sensor. Repeat the process for the other temperature sensors and compare their indicated values with the actual temperatures. After all the initial information is obtained from the self-diagnostic system, you can turn to the detailed troubleshooting section in the diagnostic manual. First, though, you'll have to remove the panel in order to connect the socket box. The connection is made at the left side connector for the push-button control unit. Using the chart in the diagnostic manual and a DMM5 or Fluke multimeter, you can now begin detailed troubleshooting. For example, test step 1 calls for checking the in-car temperature sensor by bridging terminals 19 and 20 on the socket box, and then checking the resistance between terminals 11 and 20 on the socket box. One final point about the self-diagnostic display for the climate control. This system will be phased into production as of January 1990. So some early cars will not have this capability. For the early cars without the display readout, you'll use the socket box testing procedure only. Now, before leaving the climate control system, let's take a look at the replacement of the new electrostatic air filter. Access to the filter is through this cover. The element cannot be cleaned, such as by trying to blow it out with compressed air. It must be replaced every 2 years or 12,500 miles under ideal conditions. The filter should be changed more frequently if odors are present or if the vehicle is driven in a very dusty environment. The R129 uses a new method of mounting the radio. It's held in place by 2 clips mounted to the console, which then lock into the bottom recesses in the radio chassis. The clips are released by inserting this special tool. Insert one on each side of the radio. Be careful not to damage the wooden console, and pull straight out. Now, incidentally, if the radio goes into the anti-theft mode, you can now reactivate it yourself using a 4 or 5-digit code entered through the push buttons. Just like the key codes, the radio code will be provided to the vehicle's owner on a data card. Now, let's look at some electrical components. Turning our attention to the alternator, you'll notice that both the M104 and the M119 use a new 100 amp alternator as opposed to the previous 80 amp alternator. An open in the voltage regulator circuit, which would mean a discharging battery, will be indicated by the light in the instrument cluster, similar to previous models. However, on the R129, the light will also indicate an overcharging condition. A maintenance-free 92 amp hour battery is installed here in the trunk. 2 cautions you're probably familiar with bear repeating. First, to avoid damage to the R129's electronic systems, always disconnect the negative battery terminal when charging the battery. Second, don't charge any Mercedes-Benz battery at a rate exceeding 10% of its amp-hour rating. For the R129, that means a 9.2 amp maximum rate of charge. The battery positive cable is routed through to the X410 terminal block located here, near the right side firewall. You'll see the connector under this plastic cover. Here's an important point to remember when you're troubleshooting any unusual electrical problems. A loose or dirty connection can cause problems such as flickering ABS or alternator lights, excessive voltage drop, or problems with the soft top operation. Since you've already seen in the first tape how the soft top operates, we'll look next at the system's theory and diagnosis. We'll divide the system into 2 parts, electric and hydraulic. Basically, the top mechanism is operated by hydraulic pressure from a pump located here in the trunk well. The pump will operate only when switched on by the N52 control unit located here. The control unit receives 3 inputs from the top switch, the left front ABS wheel speed sensors, and the 10-second safety lockout signal. Remember that for safety reasons, we don't want the top operating when the car is moving, which is why we take a speed signal from the ABS. Also, we don't want someone inadvertently hitting the operating switch with the car idling, which is why we have a 10-second lockout signal for the hardtop. Here's what happens when you move the switch to open the soft top. The control unit runs the hydraulic pump after checking the safety inputs. First, the control unit lowers the windows and the roll bar. The window signal comes from the S21-8 and S21-9 window down limit switches, located in the right and left doors, respectively. The roll bar is lowered hydraulically with pressure developed by the pump. The S83-1 roll bar retracted switch signals the control unit that the roll bar is down and lets the top opening process continue. Next, the control unit directs these valve blocks to unlatch the rear bow locks. The electrical switches on the locks signal the control unit that it is opened, and the sequence proceeds. Next, the rear bow is lifted to the vertical position by the hydraulic cylinders. Just as with the rear bow locks, the control unit sends an electrical signal to these valve blocks, which then supply hydraulic pressure to the operating pistons. The S84-6 switch tells the control unit that the bow is in the vertical position and that the opening process should continue. The control unit then unlatches the compartment cover by directing hydraulic pressure through the valve blocks. A signal from the S84-5 switch tells the control unit that the soft top compartment cover is open. The next step in the sequence is for the control unit to unlatch the soft top at the windshield frame. It does this by opening the appropriate valve blocks to allow hydraulic pressure to operate the left and right lock cylinders. Electrical switches in the locks inform the control unit when they have been unlatched. As with all other steps in the sequence, if the control unit doesn't get the proper signal, the process stops and a fault code is generated. Okay, with the soft top open at the front, the soft top can now be folded back into the storage compartment. Again, the control unit opens an electrical switch in the valve block. Hydraulic pressure from the pump operates the pistons that fold the top back. When the top is stored, the S84-3 soft top switch signals the control unit to continue. The control unit then closes the soft top compartment cover. After the compartment cover has been latched down, the control unit raises the windows to their original position and raises the roll bar. When troubleshooting, remember that the top opening and closing process is a sequence. The control unit is the system's brain. It will only go on to the next step in the sequence when the switches tell it that the previous step has been completed. The hydraulic pump is the muscle behind the system. It develops the pressure to work the operating pistons. The pressure will only be routed to the piston when the control unit opens an electric valve in the valve block. The only way to troubleshoot the system is by following the same methodical step-by-step sequence that the control unit goes through. All the component locations are shown in the diagnostic manual, as are the preparation steps required before troubleshooting. You'll get access to the blink code for the system through the X11-4 diagnostic socket, as shown in the diagnostic manual. Before we conclude, let me show you some disassembly procedures for the door panels, the interior light panel, the climate control panel, and the seat cushions. The door panels are removed by first lifting out the wood trim around the latch to expose the retaining screw. Remove the seat switches. Lift out the trim for the rearview mirror. Next, unscrew the trim pieces at the door edge. Do not try to lift the panel straight up, or you will shear the pins off. Unlike some other models, the R129's door panel is retained with push-type pins. The climate control assembly is push-fit in the dash. The best way to remove it without damaging the wood is to remove the radio and push it out from the rear. To remove the panel for the interior lights, first remove the mirror. Next, remove the 4 screws. The seat cushions are retained with Phillips screws, located near the line of the seat seam. Simply remove the screws and slide the cushion out. The seat back comes out after removing the screws on the back panel. And lifting it out. We realize there's a great deal to be learned about the R129. Future Education for Excellence programs providing more in-depth coverage on specific areas are now being planned. These postage-paid cards were packed in the vinyl binder containing the R129 tapes. They were put there because we need to hear from the technicians who view the programs. Ask your service manager for the cards and write to us. Your input will have a major influence on future Education for Excellence programming.